Gibbs free energy is a very useful concept in thermochemistry. Amongst other things, it is a convenient criterion for spontaneity of a process or reaction. In other words, it can tell us whether a reaction will be happening spontaneously or not. So far, we have talked about enthalpy, or more precisely, we talked about change in enthalpy, delta H. And we have seen that that change can be negative. In that case, we have an exothermic reaction, where heat is leaving the system, or the change in enthalpy can be positive, and in that case we have an endothermic reaction, where heat is entering the system. The problem was that this alone could not tell us whether a reaction will happen spontaneously or not. There are spontaneous endothermic reactions, but there are also spontaneous exothermic reactions. Then we looked into entropy, measure of possible states of a system, or disorder, symbol delta S. And there too we ran into a similar problem. There are processes where entropy decreases that are spontaneous, but there are also processes where the entropy increases that are spontaneous. For example, if I have a beaker of water and I lower the temperature below 0 degrees, this water will freeze and I will end up with ice. So this is a spontaneous process below 0 degrees. What has happened to the entropy? Well, I have gone from a liquid to a solid state, therefore the change in entropy is negative. However, if I increase the temperature to above 0 degrees, say to room temperature or even higher, then this ice will melt and I will end up with liquid water again. In that particular case, there is an increase in entropy. In both cases, the process is spontaneous, depending on temperature. So we could not rely on change in entropy alone to tell us whether something will happen spontaneously or not. And this is where Gibbs free energy comes in, because Gibbs free energy combines both terms, and it also takes into account the temperature of the system or the process. So delta G equals delta H minus T multiplied by delta S. In other words, change in enthalpy minus the temperature multiplied by the change in entropy. The great thing about a delta G value is that we can easily ascertain whether a reaction would be spontaneous or not. If delta G is negative, the reaction will be spontaneous. And if delta G is positive, the reaction will be non-spontaneous. Please note that this does not tell us anything about the speed of the reaction. We would need to look into kinetics for that. However, what it does tell us is the amount of energy available to do useful work. And this is very important in both chemistry and biology. So to recap, a negative delta G tells us that the reaction is spontaneous. A positive delta G tells us that the reaction is non-spontaneous. And the value of the negative delta G gives us the energy available to do useful work.